I guess I better say something for the live recording. I'm just setting everything up and waiting for people to show up for a moment. Let's see if I can view my own stream on the other computer. Yeah, there we go, all set up and nice. Zero watching and somebody says depends on the usage case. I've got no idea how that's happening. What usage case? Although I suppose it does work for this usage case since I just want to see the chat without having to turn my head all the way around to see the other monitor. Oh, hey, now it says one watching, so perhaps that's you, simplexicated. Oh, that's horribly delayed. Hey, no, there's 3 people. Hello everybody, I'm just setting everything up. Trying to make it run somewhat smoothly. I've got... seems to be quite a bit of a delay today. Just... let's see, that would be... yeah, seems to be over 20 seconds of delay. Yeah, there we go, like... 35 seconds of delay, which is a bit annoying. I'll just close it down on the other machine. This is the joy of ADSL, I've got 0 bandwidth to work with. Anyway, some people are starting to show up. Hello everybody. And yes, Felix Brown, there are so many cameras, I'm so professional. I bought a heap of USB cables the other day, so I might even be able to set up even more cameras in the future. But then we're going to start running into issues of fitting them all into 720p at 800 kilobits per second. Anyway, I'm going to be working on this box today, which is an ancient timer module that I'm going to try and use to toggle my solar inverter from running just straight off a grid or pulling power out of the batteries. Because right now, at the moment, I'm just... I think I might have mentioned it in a video actually, I'm just manually toggling the main supply to the old APC UPS that is my inverter. And that's a bit bothersome. But this thing should be working just fine, except the relays, I think they are mechanically just destroyed. It's a quad channel timer, 4 single pole switched outputs, and it should be quite suitable for just killing the power. I used one of these timers already for my car heat in the morning, and it's worked quite well, except it's horribly cumbersome to program. You've got the instructions, then all of that stuff is just how to program the timer. So you really want to set it and forget it. I think this one also has a bit of an issue where it'll... I don't remember if it's trying to recharge the 9-volt battery or if it's trying to discharge it all the time. But we'll have to test for that. I think I had the PCB board out already, so it should just pop out with a bit of effort. It's a very snug fit getting this board out, I can tell you. They certainly have relied on their manufacturing tolerances. There we go. PCB out. And oh wow. Yeah, these relays are done for. Perhaps I can get you a better shot of that. Hang on. Let's see if I can break the camera. Okay, I don't think we really have a proper resolution, but the black stuff in there is not supposed to be black. All of those are just not supposed to be black, and it's all... I'm not really certain what's happened actually. It seems as if there's been some horrible arcing, because the actual relay contacts are up here, but it's all black and horrid down there. And in the other time when I fixed it, the relays were just making a horrible noise rather than actually switching, so yeah, that might have something to do with it. I didn't notice that in the other module though. There's something different wrong with this one. I'm really not certain as to what's actually causing this. In fact, these relays are a quite odd construction, because well, you would expect it to just be mechanical linkage here to make the contacts move a bit, but it seems to be passing some current through there as well. But if we look at the board, there's no trace pulled out. These three are the relay contacts. So, just weird. Anyway, I'm waiting for the desoldering pump to warm up so we can just get these out and test them with the lab power supply. And as always, do get in the chat, be social, enjoy yourself. This is not some kind of planned event where I'm gonna be putting too much effort into making... Oh, now the stream looks all horrible. What's going on? Oh. Oh, right. Yeah, there used to be a text underneath the right-hand camera, but that's been covered up by the camera window since it grows larger when you enter the 5x zoom mode. But with zoomed in view, it looks pretty okay, so I think I'm gonna leave it like that. Right, so this thing should be warming up. Yep. The general construction of these timers is, as you can see, we've got this power board, which is taking up most of the space inside, and then there's the computer down there. Let's just get the relays out. It's odd, people are always asking for live soldering. I don't really understand why. Soldering's hardly very exciting. Well, in this case it might be, because this is an old dual layer board, so we've got conductors on both sides and no real through plating to speak of, so getting heat up to the top layer is going to be a bit of a bother. And I failed there. Well, it's just a question of adding a bit more heat. Well, that sounded better. That contact came loose, so let's just do the others. Oh, 9 people. For those who are just joining, underneath that distorted image in the lower right hand corner of the screen, it should say issue, broken relays, but it's covered up because I ruined the camera. But we're just gonna swap relays in this old timer module, and there the first one came out. So let's just try and click this a few times, because on the other ones they just made a horrid noise. Nothing horribly losing there though. I think these are 12-volt relays. So let's see if it clicks. Yeah, it does click actually. So can we figure out why it's turned all black and horrid in there? This is perhaps supposed to be black and horrid. Yeah, I must be wrong. It seems like we've got a black piece of plastic in there. Yeah, this actually doesn't look too bad. Actually, it doesn't look too bad at all. That's weird. I thought the relays in this box were shot. They were most definitely shot in the other one. Nothing is more relaxing than the sound of a desoldering machine, I suppose. And good morning to you too, WOOX2K. So let's just test the resistance of the relay. I should just change this ever so slightly. And get a couple of proper test leads. Are we gonna get any continuity? Well, that looks just fine, I would dare say. What's our lead resistance? Let's just turn the beep off and zero that out. Alright, we've got basically 0 lead resistance. Not enough to be an issue. And we actually have 0.6 ohms in the relay there. Now that's a bit high, I would suppose, but it shouldn't be enough to cause any major issues. Show it letting the smoke out or riot. There's not really anything to let the smoke out, or we're just playing with a relay at the moment. Oh, there we go. Now we have 2 ohms. Yeah. Yeah, this relay is not a happy relay. This is 12 volt relay. It actually doesn't say. But they really should be 12 volt relays. Yeah, we've got 12 volt 8 pits on the transformer actually, so it's gonna be a 12 volt relay and it's shot. So I wonder if I actually have any replacements. I remember these having a bit of a weird pin out. But they were just ever so slightly wider spaced than a normal relay you'd find in something like an APC UPS. Well, let's just zoom the camera back out. There we go. Wide angle. Charred contacts. Yeah, they could probably be a bit charred. I mean, these relays have seen a lot of actuation. During their time. I think they ticked a couple of times a day for about 15 years or so. So let's just test the other ones and see what they do. We do have the lovely old PCB solder / flux smell on this board. I wish this was a smell-o-vision. I just want to thank you again for the info you were able to give. I will use my test bench PC to test everything. Okay, good luck then. Is this one coming out? Yep, it's coming out. It's really confusing. I've got, on that screen, I've got the delayed stream that YouTube's given me. And I've got the live feed on my right side on my big monitor. So it's really confusing to see when I'm looking at the delayed view that I'm going, hang on, my arms aren't there. Why the hell are my arms not where I put them? And what's the resistance of this one? 2 ohms, 5 ohms, 3 ohms, 1.7, 2.3. Pretty good random number generator. The other contact is probably not going to be better. 3 ohms, 1 ohm, 1 ohm, 0.7, 5 ohms. Yeah, it's done for. It's done for. I think it's clogging up actually. I have been surprised by the quality of these desoldering pumps though. I've got one at work as well, and it basically sits turned on 8 hours every 2 or 3 days a week. And I haven't even had to replace the tip on it yet. It's just been excellent, really. I have noted a really annoying thing about the auto sleep feature on them is that if I keep using it like this and pressing the button, it doesn't reset the sleep timer. So you have to just turn on the station once an hour. Or just not use the automatic sleep timer feature, which is a really nice feature, because it just it prevents you from forgetting to turn the iron off and, you know, burning out your tips, and they're pretty expensive. So I would petition all year for a firmware update to resolve that, because it's annoying, especially if you're in a production environment. Although then I guess you would be using it all the time, so it wouldn't really matter. So what this relay like? 0.3 ohms, 0.8, 3.2, 0.8, 1.08, yeah. I think it's pretty safe to bet that these are all going to be bad. I have an all-year soldering station, works flawless with a third step since 2010. That's nice, Felix. Although the older tips, I have a friend who actually has an older version of the all-year station, and his tip doesn't take tin at all. It's just like made out of iron or something. And the newer tips, like the one I've got on this one, they actually, yeah, you don't really have a resolution, but the tip of them, a very large area of it actually takes tin, which makes it so much easier to actually get a good thermal bridge to the joint. Where is FF Cossack from? I'm from Finland. The place where summer equals rain and hot weather equals 10 degrees Celsius. And rain. Waving from the US. Waving back from Scandinavia. Quick note on using these desoldering guns, which is a technique my boss taught me. When you're doing like through-hole components like this, it's a good idea to just move the tip around a bit like this while you're sucking it out. It just prevents the sweat bridges from happening when you've taken most of the solder out, and it just helps you extract more. Good tip, and not entirely obvious. Let's just test this relay as well for, I don't know, prosperity. Place your bets for resistance. 0.2 ohms. 0.2. 0.2. Hey, this one actually works. We've got one good relay. Oh, but it doesn't work in the other direction instead. Oh no, that's hooked up wrong. Silly me. Yeah, it's pretty okay. Ah, no, it's... yeah, 0.8 ohms there. Not very good. Yeah, your neighbour, greetings from Estonia. Well, greetings to you too, Estonia. Where in Finland exactly? Since I think your PC was in Swedish, not a lot of places here in Finland that have a Swedish-speaking population. I'm from Åland, the island between Finland and Sweden. Where I think we're the only place in the world where we are actually unilingual by law. There's a law that says that we are not bilingual Finnish-Swedish, so there you go. We are only Swedish. Well, so I'm gonna have to try and find some new relays for this. And I don't have any new relays, so it's gonna have to be some old used crap. don't remember what was weird about the relays and the other one of it, because there was just something about them which made standard issue relays not work. I don't have any standard issue relays in this drawer, so I'm just gonna have to have a dig around for a donor board. I'll be back in a moment. Back in a moment. Here's a random APC PCB, which has a single relay on it, so I'll just desolder this and see if it'll do any good, or if it's just going to be the wrong pinout and I'm going to have to order relays for this. This is a dual layer lead-free board. Oh wow. You don't have resolution to see it, but they've just drilled stupidly large holes for the relay. It's like a millimeter in diameter. Oh wow. Giant holes. That's really odd. They just put really giant holes for all the pins of the relay. Makes it really easy to desolder. Really easy. I keep thinking the pump is getting clogged, but I think it's got to do with the fact that I put genuine Heiko filters in it the other day, and they don't flow as well as the original crap I use. Wrong pinout wouldn't be as bad as wrong voltages, so that's a fair point. Is this the right voltage even? It should be. Yep, 12 volt coil. Let's see if it fits. No, it does not. Yeah, that's the oddity about this board. It uses these relays which have a slightly more dense pinout than the more modern 6-pin relays do. But I can probably just bodge that together. Yeah. Just gonna find me 4 relays off of a random donor board, so I'll be back again in a moment. Alright, so we've got a few more relays on this board. That one's going to be okay enough. Now these other ones are just single pole, single throw. Yeah, these aren't going to do any good. But we've got one usable relay. Seems to be identical to the other one I got, so let's grab that one. I could actually fix the camera as well. There you go. The thermal capacity of the diesel room pump is actually pretty okay. I would almost argue it's better than the old hay case we've got at work as well. Might have slightly better thermal contact to the tip from the heater. Might have to do with it just being less worn out and burnt out though. Oh, do another relay. Is it his white underwear there? I don't think I'm wearing white underwear now. And hello there, GTA 5 FTVW. That's the second relay now. I've got to find another board. I'll be running out of boards even. By the way, this one was one of these really odd APC UPSs that you're supposed to mount on the wall. Really weird form factor. Really weird. Okay, I'm out of bare boards, so we're just gonna scrap an entire unit. I've got so many of these crappy APCs that they're just disposable to me. No idea if this works or not. Just grab straight out of the trash. It'll make a nice donut. This is a 700 VA UPS bar for one. Do we have a suitable relay? Yes, we do. And for record, this is like a 200 VA transformer in the 700 VA UPS. We're just going to run it until it saturates and overheats if you put a larger battery in. Quite calculated. This one also does the giant relay holes thing. Oh yes, for the paper towels, I've got a couple of... I think I made a video about it. I've got a couple of rails going along that way towards my back, and then I've got just a round steel thing going across like that, which I can hang stuff off of. Very useful indeed. You do get used to being able to just pull paper off like that. When I'm at work, I don't have this setup, and I keep just reaching up and going, oh, there's no paper there. Oh. I've been desoldering so much that the tip has oxidized. And it's unable to make a thermal connection anymore. Keeping the tips clean on these is a bit of a bother. Just has to flux it a lot. There we go. Nice and shiny. 700 VA of crappy modified sine wave. Yes, scrap it good. Yes, indeed. I've actually got an even cheaper version of these made by Powerware, I think. And I was going to make a video just comparing the insides of one of these APC ultra cheap units to a Powerware unit, which is even cheaper. But I just haven't gotten around to it because they're so similar, it doesn't really matter. These relays are all identical. Exactly the same model number. That's nice to know. Hope they actually connect in the right way compared to the other ones, so I won't have to make any major modifications to everything. I still need to find another relay though, since this is a quad channel timer and we've only got 3 new relays. Oh wow, we're being watched by 15 people. To everybody who's just joining in, I'm repairing this timer module, which has bad relays in it and no other faults. I've ripped out the old relays and I'm scavenging my junk piles for new relays to put in. The last relay having come from this scrapped APC UPS, which is going to get even more scrapped since I want this PCB in the PCB pile and the case in the trash. Rip and tear. Rip and tear. There we go. These transformers make you actually relatively nice lab power supply transformers. You can usually get about 20 volts out of them from the 12 volt UPSs, and they're good for a few amps. And they can run at stupid high temperatures, so it's useful. And these cases actually make excellent extension cables. You just connect the outlets straight up to the input wire, and you have this really broad and sturdy extension cord. I've got a few of them lying around. You know, an 8 outlet extension cord is relatively expensive. They even got the fused protection. Although it's just going to be a couple of amps, so I usually just don't bother using those. But yeah, they honestly have more value as just an extension cord, since you don't have to replace the battery. They are maintenance free. I got a Powerware 9305 15 kVA for free. That damn thing is a beast, free pace and pure sine wave. Could not scrap that. No, we shouldn't scrap that. I mean, it's probably doing that silly thing where it has a 200 volt battery pack, so it's gonna be a bother trying to get, you know, any batteries for it. But I mean, if you ever ran into a giant pile of telecom batteries like I have, you could just, you know, UPS your entire house, which could be of value depending on where you live. Anyway, I'm gonna put this aside and find a final board to steal some relays from. Back in a moment. device has a back UPS RS800, which has some weird internal fault. I don't think it works. It could be 24 volter. Yeah, it's a 24 volter, so it's gonna have 24 volt relays probably. Let's just have a look. Oh, it has entirely different packaging on the relays. Yep, no good. Gonna have to find another one. "48 12-volt batteries. That's silly. Mr. Hack for Never, at first I thought this was an upload. No, this is live. You are seeing this transmitted live over ADSL from Finland. Hello and welcome. Geez, do my uploads actually have this poor quality? I better up my game. Anyway, I'm gonna put this aside, find another board, be right back. Hey, look what I found. Another one of these. Gonna get turned into an extension cord. Come on. In fact, I could actually use one of these in conjunction with the timer module to just make the outlets. That wouldn't be too bad of an idea. Although the outlets are in groups of 4 with just rails going that way, so it would be, I'd have to either modify it quite heavily or use 2 units to get all 4 channels out of it. How many UPSs do you have laying around? A lot. We are talking about more than 25, less than 50 probably. I just grab them whenever I can find them in the trash, really, because they're useful for parts. Sometimes I can sell them for cheap. I mean, like a couple of years ago, I did this video where I just put batteries in 1 million of these and yeah, sold them. It's relatively good business if you can get really cheap batteries, but it's a bit of a bother. And we've got another identical relay here. Different color board though. An electronics nut can never have too much stuff. Well, you can. I would argue that you can have too much stuff. It's just a question of the nature of your stuff. A few years ago, I just had so much random garbage lying around that I couldn't make any use of. And then I threw away like 2 full pickup trucks of crap, and I haven't been sad about doing that either. You need to be a bit selective. My family has hoarding tendencies as well. So I've got to be on my watch so that I don't turn into a major hoarder. Like the ones you see on TV. At the moment, I've actually got way too many of those fucking telecom batteries. If there's anybody from like Finland or Sweden watching, I would like to get rid of a few of those. I will sell them for a very good price. Those yellow 170 amp hour telecoms I have. I don't want to throw them away. Most of them are just fine at like... The worst ones are like 120 amp hours and they're perfectly usable and going to be fine for another 10 years, but I can't physically fit more than 20 into my own solar system. So the rest are just sitting around rotting. Does the stream keep hanging for anyone else? Pinkorek, I can see that my stream health is yellow, so I would imagine it might be in my end. If anybody else would like to comment on whether or not the stream is hanging, I might try and... it's a bit... I can't change... I don't think I can change the encoding settings live. Give me a moment, I'll try and lower the... Oh, not hanging there. Okay. Well, if it's not hanging for somebody, then it must be good. It should be streaming at like 800 kilobits, which is like half of my upload rate, so it shouldn't be a major strain. But, yeah, I don't trust ADSL. It's a shit technology. If this was my own property, I'd put get fiber, because it's very cheap around here, but since it's not my property, and I know that the owners of that property would not enjoy the fiber, and they'd probably just cancel the service as soon as I moved out, I'm not going to bother. But just getting the cable installed and everything is like €2,000, all inclusive, and then you get unlimited 100 megabit up and down access for $79 a month, which is really very good. But yeah, it is a €2,000 down payment to just get the wire installed, and that's not, you know, something you just give away to a property you don't own. Okay, so now we've actually got a few relays to play with. Now I better check if these actually work. Since we're just out of random used UPSs, I don't really expect them to be perfect. Or rather, expecting them to be perfect would be a major mistake. Probably 2-pole. Meter, please. Yeah, that one's fine. Practically 0 ohms. And the other end, perfect. Other pole, perfect. Are these dual or single? They're dual. And final pole, perfect. Absolutely perfect. Here I could get 300 megabit for €30, but to get the fiber to my house would cost about 20 €, so I'm stuck with 25 VDSL. 20k to get a cable installed, that's silly. That's just silly. Maybe we can actually see the meter now. Oh, that relay is good. This one. Oh, hello, 7 ohms. That's not very good. Let's give it a few clicks. 15 ohms. That's not very good. 2 ohms. As the other contacts. I mean, it is normal for relays which have been sitting for a while to just be kind of high resistance since they oxidize. The other pole seems to be okay. The other one's also okay, so let's just cut some current with it and see if the issue goes away. Just gonna need a couple more test leads. Let's just do like 10 volts on the power supply. Give it a bit of a workout. Yep, now the issue's gone. It was actually showing you can't see the power supply on camera, but it was showing about a voltage drop across it when I first hooked it up, but now it's down to 0.1. Yep. So that cleared the issue. Maybe I can actually get it on camera for you. There you go, so you've got the... this is the one that I'm shorting out, and that's the relay supply. So let's just do the other. Nice beard, thank you. So let's see if we can get the same issue on this one. So we were getting about a volt of drop at first on this. Oh crap, I'm melting my test leads. Yeah, we were getting about a volt of drop there when I first hooked it up with 300 milliamps. Let's see if this one does the same. No, this one's fine. Let's just click it a few times anyway. Right, so this one gets a pass. The other one already got a pass, and now we've got the next relay. Oh, I should measure it before I just start loading it down. Now we're grossly out of focus. There we go. Well, you guys are talking about many megabits of upload speed. I'm jealous. I've actually considered just getting a 4G connection to the YouTube uploads, because uploading at 1.5 megabits over ADSL is just a pain. This relay seems to be okay. Just fine. This one seems to be keeping up a trend as well. Relay number 4. Looking just fine. Oh wow, we've got 24 viewers. To those who are just joining in, I am fixing this board, which is a Finnish timer board, which has bad relays. I've taken the relays out and pretty much made sure that they are gone. And now I'm scavenging relays of a random APC board to put them in there. And I'm just testing the used relays to see if they're any good. Final relay testing, and that's just perfect. So, and we've got 4 good relays now. Good enough anyway. So now we just need to figure out a way to mount these onto this board. Because the pin out is not entirely identical. The pin spacing is different. And we need to cut a few. Hang on, do they even go the same direction? I hope they do. Else the on-off is going to be inverted. So that's open there, closed there. Oh wow, this one's going to have to 300 ohms. That's not good. It's closed in that direction. And closed in that direction. So we have the same, they connect in the same order, which is a good thing. But, yeah, these are a bit annoying. These are dual pole relays. The originals are single pole, and the originals connect between the left side center pin and the right side outer pins, whereas these are dual poles, so I'm going to have to bridge out the 2 middle pins on them. And yeah, that'll sort out the issue. It's an extra step. It's not going to be an issue though. Just have to solder some little wires onto them. And I'm going to have to figure out a way to actually mechanically make them fit into the holes. Oh wow, that's actually... Are these? What am I doing wrong? Oh yeah, there we go. Yeah. Need to kind of bend the outer pins inward slightly. The middle pins is the right... Oh, did the stream just go to a horrible low resolution mode? That looks like shit. Well, let's just hope it's... I don't know. To me, on my monitor computer here, which is watching YouTube to view the chat, I like streaming at 240. Stream is fine here. Okay, then it's just me. I should just... can I, like, stop watching? Can I, like, kill Flash Player? Let's kill Flash Player. $720p HD. Okay, then. Well, then it's just in my end. There we go. Flash Player plugin. Die. Let's hope the chat keeps working. There we go. Now I shouldn't be bogging down my connection by watching what I'm streaming. Righto. So I've got to bridge out the middle pins of these relay contacts and just solder everything together. Kind of bend the pins a bit, but that shouldn't be much of an issue. Let's see if I can zoom the camera in on my soldering work. Isn't that razor sharp? Now I get to enjoy the super long cable I've put on my soldering iron. Oh Christ. I just... don't we still have audio? Yep. I just attempted to solder right across the microphone cable. Which wouldn't have been very good because I only have one microphone cable. So that would have kind of ruined everything. But we're alright. Can I get... There we go, a slightly wider field of view. I'm just gonna bridge the two middle pins together. Stream stops for me for no reason. Yeah, I mean, people, you guys, you have to keep verifying that it's actually working because it tells me that my stream health is yellow, which well, if several people are having issues, then it's likely to be in my end. But it has to be everybody having issues, else it's going to be in your end. And if everybody is having issues, then I might be able to drop the quality slightly. But it sounds weird if only some people are having issues. Then I can't reasonably do anything about that. Yeah, I'm gonna have to wrap the wire around the posts actually, else it's gonna fall apart and I solder it onto the board. I'm just gonna deep freight this wire. And do something like that. A little loop. Where are my tools? So I'll put a little loop on that. There we go. That's looking pretty alright. That should stick around even though I'm resoldering the relay onto the board. And now I want to cut one of the pins, which would be that one. short as possible. That's looking pretty okay. Oh no. Oh Christ. I just held the relay the wrong way when I was cutting that pin, and now I cut the wrong pin. It's supposed to go on that way. And I cut the pin that's going through that hole. Duh. Oh well. That's not a problem. It'll just be a bit uglier. We'll have to pull a wire from the other pin too. I can just let that be there. And add a bit of wire. Jeez, you guys have such high version numbers on your browsers. I'm using Pale Moon, which is like 20 something. What old is this device if Cossack? The layout looks like hand painted. It's an old timer, industrial timer, made in Finland from somewhere late 70s, early 80s. It's it's just very old and locally produced. I'm not certain what the brand is. It says somewhere. It says on the front panel. It's an OKK Mini. But everything goes in Finnish on it, so it's gonna be a local Finnish thing, although they seem to be a bit more professional than most of the small electronics manufacturers over time. Some of the old Finnish stuff really looks very dodgy, but it's usually of very high quality. I'll just carve that there. And we'll put some more solder on there. Like so. Now let's see. Replacement pin. Probably want to solder that a bit better though. Actually tack it down in both ends. Okay. Like new. Perfectly serviceable. And now I want to cut the other correct pins, which would be these two. Snip, snip. Snibbity snib. And I will just have to bend these two other pins inwards ever so slightly in order to get it to fit through the holes. Something like that. Right, let's see if it'll actually... No, I've got to Get the pins together ever so slightly more. There we go. Yeah, this is definitely a hand-taped board, by the way. Urgh. Oh yeah, I think that'll stick around. Yeah. Not gonna make the best connection. But I think this, yeah, these holes actually are through-plated. I think. So, yeah, they're through-plated. So it should be perfectly workable to just mount it, even though the pin isn't sticking out all the way through the board. So let's just solder that in place. I love this, at least it doesn't look like designed by NPT. Yep, well, curiously, I mean, this device is a relatively sophisticated computer. Well, this particular board is just the power board. But there's no... yeah, you can't see it in front. Yeah, you can see in the lower camera. In there's actually a big computer box, which is relatively advanced. You can program a lot of stuff, lots of different parameters for how the timer is supposed to work. I mean, this is, you know, a computer designed company who made this, no doubt. There we go. That shouldn't be going anywhere. I want to resolder these. These screw terminals here, these solder joints look a bit worn on them, as they tend to do since there's a lot of twisting force on the actual solder joints. There's so much flux residue that I barely even have to add any new solder. If you think I'm soldering slowly, by the way, I'm using a relatively low tip temperature. I just prefer to have a low temperature and solder slowly. There's less risk of breaking shit. Unless you're like doing something specific with just to take, you know, some device which is damaged by prolonged heating. Then you have to ramp it up. When the test of this timer is going to happen, magic smoke will be contained. Well, we'll test it as soon as I've got all the relays installed. So we've got 3 more relays to go. 3 more relays to ever so slightly modify. I don't think there'll be any smoke though, since we're just swapping the relays. And I know that the actual timer works. I have started it. It just didn't do anything at first because it was, you know, the relays were at like 2 ohms, so it wouldn't pass any considerable amount of current. The relay contacts would just get hot in a second and go open circuit basically. Right, so it's that's the pin we want to cut. That's the correct one. But I still want to... I want to add the little jumper wire before I cut it. Else it's just going to be annoying to put it there. And we'll do it like so. Do a little twist like so. And cut it. Like so. Oh, no possibility of smoke. Entertainment value drops. Yeah, I'm sorry. I generally try to avoid smoke on products I like. And if I didn't like this, I wouldn't be, putting a couple of hours into repairing it. I actually have got, I've been intending to make a video about it, a few eBay AC adapters, which are probably quite lacking in, well, everything. But I haven't gotten around to it. I'm also going to do a video of that overpin amplifier I did a live stream on earlier. Probably blowing that up as well, so there's some smoke coming up on this channel, but not tonight, I'm sorry. Right, let's just verify that we cut the correct pin, and that would be this one. Snib. Snibbedy snib XD. And then we want to cut the corresponding pins on the other side. So that would be these two. And we want to bend these two. Gah. Like so. Oh yep, hole in one. Oh, that's beautiful. Perfect fit. This is a bit awkward. Quite awkward indeed. The board can't balance on this relay like it could on the other, so I'm gonna have to do it manually. There we go. Not going anywhere. By the way, this microphone stand I've got, I think it was like $12 off of Banggood, which is pretty insane. To imagine that you can even ship something the size of a microphone stand for $12 is just pretty impressive. Ah, there we go. Relay number 2. I just can't hit perfect temp while soldering, but that may be connected to different age boards I solder, desolder, and extremely different sizes of solder things. Well, Mecha Drake, what you're soldering is obviously going to affect the temperature you need to use. But more than anything, what I've found matters more than anything is the thermal capacity of your iron. There are two basic designs of soldering irons. You've got ones like the OU 2901 I'm using, where you've just got the heater right at the tip and extremely low thermal resistance there. Or you've got something like the desoldering pump, where you've got a heater, which is like the entire metal tube is the heater, and then you've got the tip at the end, which is just a large metal mass. And well, like this is going to work by just heating the tip up to a rather high temperature and then dumping that heat into the joint like a capacitor, whereas the 2901 style stuff is going to just to have a very low thermal mass on the tip and dump heat in by just using the heater. And the 2901 style irons can just use a much lower temperature, since you don't need to have that thermal capacity, so-called capacitance, because you just slowly heat the joint up to the desired temperature. So it really depends on your iron. I hear noise in the background. There are a couple of noises. One is my bench PC here, which is making a bit of a rattly fan noise. There's something wrong with it. Beyond that, though, there shouldn't be too much noise here. Not too much noise at all. And the mic itself, yeah, this is the, I think it's called a BM800 microphone. It's one of those $20 cheapos. Yeah, I think it's also from Banggood, actually. It seems to be pretty okay. It's about the same performance level as my old DIY microphone, except it's a lot more sensitive. Oh wow, there's nothing showing in this screen. My iron is too small. Some Chinese pros kit. Desoldering motherboards caps off the ground plane sucks. Thermal capacity not found. Yep, Mechadrag, you're not going to be desoldering motherboard caps with a pros kit. We actually used pros kit stuff at school, and they were like these just constant power 15 or 25 watt irons, which were pretty bad. The Bomber 18112, please give me a shout out. Okay. I'm not going to shout your name though, because it's pretty late at night. Also, I think you reach more people by the chat than just having me say it, since there's literally 16 people here, and probably 15 of them are in the chat, and the last guy is just going to be AFK. Thanks so much. Well, you're welcome, the Bomber 18112. I'm glad to have put forward your name to 18 people. I hope I didn't, like, just advertise some child porn distribution network or something. I don't know. That would be kind of cool, though. But I have odd opinions on stuff like that. Those are the so-called premium grade sleeve bearings on those Noctua fans. Well, this computer's actually a Dell with like NMB or Delta ball bearing fans. They're just no, they are Senaces. Actually, I can see through the rear grille. They're not too bad fans, but they're just not very well suited for a PC, since they're very loud to drive. Like, it's not bearing noise, it's just the phase noise from the two phases kicking in, the pulling the blade between phases. It's just very loud at low speed. The fan blades don't have enough mass, so they just jitter slightly. Any ideas on oil for telescoping whip antennas? I've got no idea. I've never seen one of those get stiff. Right, let's just make sure we cover the right pin on this relay as well, and that would be that one. I'm not gonna try and do a Dave Jones impression even though everybody's doing it in the chat. I'm not Australian enough. And let's also make sure we cut the other 2 pins correctly, which would be these 2. Let's make this one a perfect relay. I don't really like relying on the through plating on the board to connect my circuits, but what you gonna do? I can't be bothered buying new relays for these. And that's now it's done. The annoying weird thing, the soldering pump has just turned itself off. And it's been off for a while, so I've got to reheat it. That's how you cheat. I'll see if we can get that in frame. Because it takes ages to get the heat from the actual heating element into the tip, so actually just using your normal preheated soldering iron to heat it up does do quite a lot of good. It takes like 5 minutes to heat up otherwise. There we go, back in business. Let's just not get too much solder this time. There we go. That's pretty okay. Oh yeah, that's the best fit yet. It's just grazing the top of the holes there. I want to put a bit extra of a spin so that it'll just properly flow out through the other side of the hole. Make a good connection to the little bar I've installed. Right, this is going to be the last relay. one. There we go. Oh wow, the viewers count went down one and then up one again. Perhaps we're joined by someone new. Hello, somebody new, in case you knew. Yeah, it should say what we're doing. Yeah, it doesn't say what we're doing. We're soldering relays is what we're doing. We are soldering relays because they have a wrong pin out. That's what's going on in this stream right now. And because we are professional videocasters, that's very clearly stated in the metadata, of course. Oh wow, I even forgot to... I forgot to redo the title for the video. People are probably going to be confused. I forgot about that. Oh well. Have to change it when it goes into download mode. But yeah, this is obviously not a Lipin LP838 unboxing. That's for certain. Jeez, I'm a trickster. I'm fooling people. Clickbaiting. Alright, so let's cut some more pins. That one's a goner. And those two are goners. Snibbity snib. Axe there. And bend the pins on the final relay. Like so. Ah, that's a perfect fit. I love work. I can watch it for hours. That sounds weird. Although I suppose it can be nice to watch other people do your work. Technically, I actually am doing like proper work now, since this video is going to be monetized when it's like in the download thing. It might be monetized now too. I don't know if you guys have ads. So I'm technically earning money doing this. That's not too bad. Very small amounts of money. Putting the profit of this YouTube channel from like minus 500 euros to minus 499 euros and 50 cents. Okay, that's 4 new relays sitting rather. I think these should work just fine. Let's beep it out before we try and power this thing up. And I've got to clean some metal crap off the bench too, so that we don't short mains to everywhere. I don't feel like putting this thing back into the box unless it's working, because it's just such a bother getting it in and out from the box. So we should have connection between that and there. Or that and there. There's just nothing on that relay. No, there we go. Oh, I might want to show you the meter as well. Let's just go into wider angle mode. There we go. Smile for the camera, little Bryman. Good job on soldering those relays. Thank you, Mr. Juby. So, we've got connection there. About an ohm, that's weird. Oh yeah, we're using my crap test leads now. These are going to be, yeah, 800 milliohms. So we've got connection there. Yes, we do. Oh. I actually didn't do a good job because I forgot to solder. I forgot to solder one of the coils. Whoops. There we go. That would have been a disappointment. Right, so that one's okay. Let's adjust manual range with meter because it's annoying to have to wait for the auto range. Okay. Oh, that one. Okay. Righto, so now let's try and power it up. Just got to move all this metal crap out of the way. There we go. That should be workable. It's happening, it's happening. Yes, it's happening. I think this timer is a little more complicated than a timer IC could provide. It's not horribly complicated. It's got a lot of buttons, but it's got dedicated buttons for all the weekdays. Oh yeah, I think, yeah, one of the issues with these is that the buttons get all horrible with times. I might have to fix that. I think it's built around something like an 8088 or something. It's just some ancient processor in it. You can program some relatively advanced patterns into it by just making the channels work against each other. And since you have like manual control of all 4 channels there, so you can like put one pattern, say Thursday, Friday on channel 1, and then you have Mondays and Sunday on channel 2, so then you can just turn channel 1 on and connect your output between channel 1 and 2. So if you have channel 1 on, then it'll be automated by channel 2's pattern, so it'll turn on Sunday, Monday. And if you do it the other way around, then you'll have it by channel 1's pattern, which would be Thursday, Friday. Which is pretty useful. You can disable them as well. And it's got a battery backup. But yeah, I remember there being some issue with the battery backup on this unit, which is why I'm using the other one right now. Right, let's see what happens. Beep. And you cannot see that display at all. I'm gonna have to kill some lights. And that made no difference. That made no difference either. It's a pretty dim display. I'll just... everything's going wrong now. There we go. That's the clock display. So let's see if the... how do you use this thing? Let's see if the buttons are all horrible like they often are. Let's see. The instructions are in Finnish and I'm very bad at Finnish. Alright, so to set the time, we're supposed to press that button. Yeah, it's got the issue with the buttons where they'll just react all the time. And then we're supposed to press kello. And that didn't work. Alright, so I've got to take it apart. Yeah, I've definitely got to take it apart and fix the buttons. Because the software is pretty stupid. If you press once and press the same button again, it'll just throw an error. And when you're moving around the menu and trying to do stuff and it keeps pressing the buttons twice and discarding your changes, that'll get on your nerves quite quickly. But we do have manual control of the relays. Now that sounds strong. So all the relays are ticking. It's just to verify that they're actually working as they are intended to. We'll go into beeper. So this should make it go beep. And it's not. Okay. This doesn't seem to be working at all. Oh no, I'm at the wrong. That's... oh yeah. This is working excellent, actually. Yep. And the final. Oh no, is it not working? Oh, there we go. Just not making a proper connection with the meter, I think. Yeah. So the relay fix did work. It's working perfectly. Excellent. Now we just need to take the computer apart in order to fix the horrible button issue. You just need to clean out the keypad. I don't remember if I tried doing this before. Oh, I've got to turn out some lights. Hang on. Right, this just comes apart with a couple of nuts here, I think. Oh, the actual timer seems to be Japanese. Because we've got a lot of Japanese characters on the back of it. So it's just a Finnish-made power board using a Japanese timer module. That's what's going on. This should pop out the front like so. These require some more force. That's the back plate. Can you see the... yeah, you can see, but there's like Japanese characters there. Lots of Japanese pictures of transistors and stuff as well. And there's the inside. The processor seems to be labelled MSM 5840H-34RS. And there's another chip called MSM 4508RS. And then there seems to be a bunch of 4000 series logic. And a few transistors for driving the outputs. I've got no idea what any of that stuff does. What's the reason behind these integrated heat spreaders? They are afraid of people to break the dice or something, and then they make bad thermal interfaces with them. Mechadrake, they put heat spreaders on because it makes assembly of the actual computer require less, sophisticated machinery, because they don't have to care about the assemblers breaking the processor. I mean, the market for homemade PCs is tiny compared to the market for, Dell. How does this come apart? I think I might have to desolder the internal speaker. There's a connector going to a dip socket. Oh yeah, I'm gonna have to label that. There we go. And I'm gonna have to take that. This is annoying. The speaker is just soldered onto the board. I'm gonna need a tiny screwdriver to get that apart. Is this small enough? Yeah, it's small enough. So it's just Phillips 1. There we go. There's the computer module with a little display and some logic on it, and that'll just rip off like so. Pretty neat construction. Very 70s looking, all of this stuff. Kosei. That must be the brand Kosei. KM8200 seems to be the model of the internals. Good luck finding data on that online. Extremely obscure Japanese timer module. I do want to get the buttons out. Oh, they are just hiding in here. Deep inside the belly of a beast. Hey, we're up to 19 viewers again. Anybody who's just joining in, we are currently fixing the buttons on the, well, a Japanese timer module from the 1980s. And the issue on it is that these pads just get dirty and the rubber button material gets all worn out. And the other one was fixed by just cleaning it out properly with isopropyl alcohol. So let's just hope we have as much luck this time around. By the way, used thermal paste tubes are excellent alcohol dispensers. Brushy, brushy, brush. Not much to comment on about this process, to be honest. There we go, that's the button stuff clean. Now we've just got to do the board as well. I think the bigger issue might be the board. I think you just get some carbon deposits between the conductors for the buttons, and they just become extremely sensitive. A lot more sensitive than they're supposed to be. And that causes the multiple triggering issue. Because there's a fair amount of just crap coming off of this. Righto. Let's hope that did it. And just put some alcohol here when I reinstall it as well. Right, so let's just get this thing back together. Hope it works. remember to bolt the speaker back where it's supposed to go. I'm glad I learned a little about electronics. I have repaired some car audio stuff and made a bit of cash. Good on you, Rex. People chuck that stuff away and I fix it. Yes. That is so true. This timer, by the way, was actually garbage. It was discarded, thrown away, because of a broken relays. They chose not to repair it because there's just no... it was basically retiring when it failed, so they had no reason to actually repair it, to keep it serviceable. Now we're up to 20 views again. Hello anybody who's just joining. We are repairing this Japanese timer module, which has issues with the buttons reacting way too quickly, causing the entire device to be unusable. We just cleaned the membrane out and hopefully it's going to work now. Capacitor plague was the best thing to happen to electronic scavengers. Yes. I don't know, Wooks2K. I would not say that the capacitor plague is entirely over. You have all this new ultra cheap Chinese stuff that gets bad caps still. Although the bigger brands tend to not have those issues, I suppose. I love this channel and EV blog, Big Clive, M. Sylvain Louis. I'm flattered to be mentioned among that heap of elites. Come on. Please go together. I'm not really a fan of the construction of this. I'm just ripping and tearing up the speaker wire right now. There we go. Something made a cable snappy noise. I might have broken the wire for the speaker. Oh well. There's a potentiometer that's externally accessible on this box. I've got no idea what it does. It's just drilled through the case in the middle of a drawing. And everything's in Japanese. This really makes no sense. I've got no idea. And yes, this is the proper tool for tightening nuts. We have 2 more. I do like the attachment. They've just used this metal thing to squeeze the timer against the back of this aluminium plate. And when you unsqueeze it, the metal bracket just falls off. Very neat. Very tidy. Very simple. Finnish electronics have a tendency to be very, very simple. Okay, that looks like a 6mm, so I think I might just bother getting a correct tool for it. It's not a 6mm, but this is good enough. Better than pliers. Right. Perhaps we can try and fire this up again. I'm not going to turn the lights off because I can see the display even though you can't. There's no metal hiding under there. Yeah, still a bit dicky, but a lot better. Definitely a lot better. Alright, I'll turn the lights off so that you can see me try and configure this thing. There you go. Oh, that's all out of focus. Oh no, we're just down at the noise floor of a camera. Right, so KLO, that's the clock button. Yeah, that is slightly out of focus. There you go. So the KLO button, it always takes it back to the clock. But you've got all these instructions for how to set this up, and they're all in Finnish, and I don't speak Finnish. But I have figured them out at some stage. Ajanasetus. Paina JPV, aseta viikonpäivä, aseta aika, paina kello, paina KS. So let's see, JPV, and I will want to select the day, so it's Tuesday. And then we want to enter the time, 13:37. Paina kellon asetus. There we go. Time set. So that works. So Ohjelman tarkastus. I don't remember what that means. Ohjelma is like happening, I think. I don't know what tarkastus is though. Paina PN. Oh yeah, I think this is like view programming. There's no programming to view. Toiminta-aikojen ohjelmointi. Päälle aika, pois aika. Yeah, that will be on time, off time. So, valitse kanava. That's choose channel. So we'll choose channel 1. Aseta päivä. Tuesday. Aseta aika. Set time. 13:38. Paina on ei. Oh yeah. Paina AAS. Okay. Now it's doing nothing. Error. Time. So did it save that? So let's see. Yeah, so we choose channel, we press PN. Yeah, and we've got it on. To turn on at 13:38. Now, the time already passed that, so we'll... Oh yeah, it does that flashy thing sometimes, I don't know why. I think it's a bug. And we want to actually make it do something, so we want to edit this. And I think we pressed PN again, then we enter the day, then we enter the time. Let's do 13:40. We should be... Oh yeah. We're double triggered on the 0, and then we got error because 0 is not valid input. Right, so now we want to do... And we choose the channel, we want to do PN. To go Tuesday. Oh, we want to do PN again. No. Choose channel PN. PN again. And now we should be able to enter Tuesday. No. This is part of why they threw these away as well. They are not easy to program. Okay, now I have no idea. Right, we're at 13:40, so we'll go for 13:41. Double trigger on channel 1. Channel 1. Tuesday. 13:41 on RRS. And I will go to kello. So now channel 1 should turn on at 13:41. Let's program it to turn off at 13:42. So channel 1, Tuesday, 13:42, RRS. Okay, and now back to kello. Hey, turned on. We've got a red LED. So now in 1 minute it should turn off again. And in that minute we might be able to program channel 2 to turn on Tuesday. 13:42 on RRS KLO, and we'll do channel 2 Tuesday 13:43 off, and that means just apply. Now we'll go to Caldo, now we'll go to third channel Tuesday 13:42 on, and we'll press that button. And channel 4 Tuesday 13:42 on, save kello. Right, so in a couple of seconds a lot of stuff should be happening. Sometimes there's a brief delay. Oh no, all channels are off. Whoops. Yeah, so we'll just... there the first channel at least turned off. Can we like set the clock to just go back a bit so that I don't have to reprogram all of that? Oh, the bomber had to leave. Oh well. Let's see. We want to set the clock, so that would be JPV, and that was it Tuesday, 13:41, and it double triggered over 1, and that gave us an error. Let's try again. Tuesday, 13:41, and core eyes. And now it's never gotten a command to turn the channels off, so... Okay, turn channel 2 off. This thing is just confusing. It's just a bit confusing to use. So we actually have to program all the channels to turn off as well. Oh, that's annoying. That's really annoying, but let's just program channel. Well, actually, let's see what it does, because it's programmed to turn a lot of channels on at 13:42. So, I don't know what it's gonna do. Okay, it turned all the channels on. So let's program all of them to turn off at 13:43. So channel 1. Okay, turn channel 1 off, okay. Tuesday, 13:43 off. Channel 2, Tuesday, 13:43 off. Channel 3, Tuesday, 13. Nope, that was wrong, so we'll just get an error. Channel 3, Tuesday, 13:43 off. Channel 4, Tuesday, 13:43 off. Kello. And let's do channel 1, Tuesday, 13:43 on. Save. Kello. Right, so now it should turn on channel 1 and turn off all the others. In 3, 2, 1. Oh yeah, there's a 10-second delay on the turn off for some reason. So, 3, 2, 1. Oh yes. So I would say that this thing is fixed as far as the timer functionality is concerned now, which is pretty sweet. I can use this for all kinds of stuff. I'll probably just replace the other timer with this one. But I need to check the battery charge circuit, because I remember there being something weird going on about it. Now you're gonna get swamped out. Alright, we've got a lot of 230 volts going around here, so let's just turn it off. Now we've lost all memory. All that programming is lost forever, because we don't have a backup battery. But yeah, I think this one had an issue where it would either try to charge or discharge the backup battery. So let's just put the meter in series for the battery and see what is gonna happen. Lovely to have a 9-volt battery though, so easy to probe. So if current is flowing into the battery, then there's going to be positive coming over there. So yeah, negative current means that we are discharging now. And we are discharging at 40 milliamps. This thing is not very efficient, but I think there's some weird thing going on. The other one didn't use anywhere near as much power. Let's just turn it on and see what it does. Oh yeah, this one just kept discharging the battery even though it got power. Now that's no good. Because, I mean, we're discharging this battery at like 0.1 C. So that would give us a pretty empty clock battery in a pretty short time. So we've got to find out why that is. And I do want to have a battery backup on this thing because it would be really annoying to have to reprogram this every time I have to disconnect it from the grid. The circuit is pretty similar though. We've just got an LM340 and a 7805. Now the battery is connected. Let's see. It's in series with a diode somehow. It's in series with several diodes. I think it's intended to have like a rechargeable nickel metal hydroxide backup battery. Let's see, so we've got a diode coming from this resistor which is going to apparently plus 12 volts. Do we have plus 12 volts at the top of the resistor? Let's find out. This is probably ground. That's a lot more than 12 volts. That's 18 volts. Then the question is, do we actually have ground in that trace I was probing? We should have ground in the negative of this capacitor though, which is there, and this should be 12 volts, and it's 18 volts. Now remember there's some kind of odd a variable thing. What's over 5 volts? A bit high, but it's 5 volts enough. That's actually a very high 5 volts. It's almost as if it's trying to sink current. 14 volts on the input. This is a bit weird. That end of the potentiometer is going to ground. The other leg, it's like at 0.8 volts. Now this transistor is doing what? 14 volts, 18 volts. It's dropping a few volts. No idea what it might be going to though. I think this potentiometer and this transistor just make up a kind of crude voltage regulator. Let's just try fiddling with a potentiometer. This is probably supposed to be 12 volts. No? Does it effectively 12 volts? Perhaps. Yeah, that's making a difference. Is this perhaps adjusting the 9 volts charging circuit? display brightness. Yeah, it's adjusting the display brightness. So it's adjusting the supply for the box, the timer box. So that's ground. 7.6 volts there. That's 5 volts. That's 5 volts. These are not very well labeled at all. Does it affect the 5 volts? Yes, it does. By a lot. That's probably supposed to be 5 volts. Yeah, I think it's by affecting this voltage that it's affecting the display brightness. I don't think it makes a difference on this one. No, not to any huge extent. Now that's ground, I think. Yep, that's ground. These two pins are the same. E 5.12. Yeah, these two are the same. They just go together on the board as well. Yeah, they're just in parallel. And we've got two 5 volts coming through those two wires. Then we've got a 7-ish volts, which perhaps it's just going from the backup battery. It's intended to go from a backup battery for a diode. Let's find out. Yeah, we've got a diode drop there from the battery connector and something with a lot of capacitance the other way, but that's turning kind of open circuit. Perhaps we've got a bad diode. That seems a bit weird. Not going anywhere else. Yeah, it's going. Oh, it's nice. This is just snaking its way around all over the board. I think the purpose is to give like backup clock keeping power on the purple wire going there, and just to supply for the clock on those two other wires. And ground. Yeah, that would make sense because we've got basically 4 wires going to the timer module and then 4 more. And that's enough for 2 power feeds, 1 9-volt backup, 1 ground, and 4 relay outputs. And that the relay outputs are obvious, going straight to the relays. So we need to think about why we've got such a big draw on the 9 volts, because there's a resistor and a diode going to the battery from something. I want to see what voltage we have on that. I think it might be the charging circuit. It's coming from, yeah, the 17 volts. And it's dropping to 9 point something volts. And it's like 8 point something. Perhaps our resistor has gone a bit bad. Because if that resistor over there is open circuit, you can't even see it. And if a resistor is open circuit, then there's going to be no charging going to the battery, which would just keep the clock running on battery power. There's the 470 ohm, and that's what it's supposed to be. So that's alright. A bit odd though, we're dropping a lot of voltage over that 470 ohm resistor. Let's see what we're dropping. We're dropping 9 volts across it, that's quite a lot. What current does that give us? Let's see. 9 volts over 470. That's 19 milliamps. So something's drawing 19 milliamps. Over that resistor. That's really a lot. Wonder where it's going. Oh! Oh, Christ! Ah, I just gave myself a big zap. Jesus. Oh, wow. And before I get into that fibrillation thing, is my heart beating? My heart is beating. What on earth did I just manage to do? That was very clearly a 230 volt shock. Between my arms, no less. Jesus Christ. Yeah, Jesus. I've got no idea what the hell just happened. Is this thing live? It really shouldn't be live. What on earth? What on earth? Well, I'm terrified. There should not be 230 volts anywhere here. Nope. What the hell is going on? We've even got the ground connected. Now that should beep out. What the hell? Yeah, it's grounded. Yeah, it's 240 volts here. Yeah, 230 volts, whatever. I just got it. That was between my fingertips. I must have touched the fuse there. I must have touched the fuse there, and the box there, and the box is grounded, obviously. Yeah, the box is grounded, so I got 230 volts just between these two fingers. Whew, that could have killed me live on camera. That's a bit of a shock. I haven't gotten 230 volts sapped in a long time, and that's probably the first time I've ever been sapped right across my body. Oh, that's terrifying. That's properly terrifying. Especially after having watched that big Clive video where he talks about people, you know, going, oh, I feel a bit woozy, better sit down and have a smoke, and then they die because their heart just starts fibrillating. But I've got a strong pulse. It's fine. Righto. Not gonna do that again. No, there's no live pin today. The video is incorrectly labelled. I forgot to set that properly. I don't think I can change it live. No, I've got to change it afterwards. I'm still recovering from that fucking shock. Jesus Christ, that was terrifying. That was properly painful. Properly painful. That is why you do main stuff one-handed. Yes, indeed. That was just careless of me. I wasn't thinking that it was mains. I mean, we've only got mains right in this corner of a PCB, right? There's no mains anywhere else. Everything else is after a transformer. I'm gonna have a cookie. Fucking hell. right across the fucking chest. Right across my hands. Jesus. Never had that happen before. Anyway, let's just turn this off and try again. There should be a 2-pole switch, so when it's off it should really... Yeah, it's entirely dead now. Entirely dead when the switch is off. That's a good thing. So I was trying to figure out. Oh yeah, we'll have an excessive current draw across the clock supply. Although we do have an excessive 12-volt rail as well. Where's that 12-volt rail coming from? It should be 12 volts. Coming from there. Going to... I did reverse engineer this circuit at some stage, but I've forgotten all of that now. Where's this entire power supply coming from? We've got the cap there. Just going to... Oh, so it goes straight into the 470 ohm resistor. So that's just entirely unregulated. There, positive on cap. Yeah, that's going straight to the 470 ohm resistor. Yep. Okay, no wonder we have a high voltage. That's just unregulated straight out of the transformer. Oh, you guys are still talking about the zap. I haven't kept up. Cookie make it better. Yes, Cookie make it a lot better. So anyway, we know that our supply is supposed to be pretty high since it's coming straight out of a transformer. But where is it going after that? We just have a diode going to there. Is it just going to be going? Straight into everything? 12 volt actually doesn't seem to go anywhere except for the... Oh yeah, there you go. It goes to that, it goes to V78. And it goes to the LM340. Oh, what's an LM? Oh no, that's a 70. Oh yeah, the LM340 is a 7805. The 7800 series regulator style thing. And that's a 7815. There's also... So we should have 15 volts there. Let's see if we do. Let's turn this on without touching the mains. That's ground. Yep. We should be 15 volts. It's 15 volts. We should be 5 volts. Is this ground? No. Weird, the 5 volt regulator is sitting at a... The ground is sitting at like a volt. That's odd. Where's that getting its ground from? I got set with 300 volts DC at a couple of amps. Some Christmas lights were acting as a ballast when I was 16. Good job surviving. Well, I'm sure it did burn your fingertips, Famicom. And yes, to those who are questioning, I am dead. And Famicom is dead too, we are all dead. We are actually spooky ghosts. The ground of a 7805 is connected after the potentiometer. So is that just adjust? The potentiometer is just set up like a variable resistor. Going to ground, I think. It should beep out. Yep. So the this potentiometer is varying the 5 volt rail by adjusting the potential between the regulator and ground. Okie dokes. That's an oddity. I still do wonder where the current from the battery's going though. Perhaps the diode is open circuit? Because since there's a higher voltage at the one side of a diode, it should be charging the battery just fine. I wonder if this circuit was originally designed to have a backup battery because the connector seems a bit tacked on. And wires are running around all over the board. We've got a little jumper in the corner that says Akku. So that's battery off, battery on. So what happens if we do just remove that and turn on without touching the mains? What's our battery voltage? 17 volts. And if I plug that in, it drops to 8 volts. Well, that's weird. So this jumper is in series with some load. Could there be a dodgy capacitor on the timer controller? That's a possibility. I should actually... What I'm trying to do right now is figure out where the battery backup is going. Like by which mechanism it's getting to back up the actual timer module. Because it's just snaking its way around all over the place. It's going to the jumper. One is going back. right across the board. And it's going to, I believe... Let's see if I'm right here. There. Yes. And it's just got a diode to... there. Yeah. So it's going for the purple wire there, as I think we suspected earlier. So it really shouldn't have anywhere to go except in through the purple wire. So if we desolder the purple wire, the current draw should go away if it's actually going into the timer module. Let's just do that. Purple wire's gone. So we should now have no draw on the 470 ohm resistor. If it's indeed going in through the timer module, else it's leaking somewhere else. Click. Wow, the timer module's going insane when it doesn't have its supply. Do we have a drop over the resistor now? Nope, nothing. That's just no circuit. So that would make this 17 volts. 12 volts. Oh, but 12 volt is actually 12 volts now. What? How is the 12? Why? It's drawing a lot more power since it's got a bunch of LEDs lit. Well, that's why. Yeah, so the 200 milliamps are going into the timer module. Let's just double verify that. We'll just clip onto the wire. Like so. And we should see. Yeah. 18 milliamps. Now there's nothing wrong with it actually drawing 18 milliamps really, it's just that the battery shouldn't be engaged when the AC is engaged. You should have comfort. Yeah, I could actually. That's actually a pretty good idea. I think I can just disable the microphone noise gate, which should give you a little background hum. Now there should be like a constant little background noise. If it bothers anyone, if you think it's better to have a noise gate on, let me know in the chat. Because right now there should be a little background hiss. And we'll see what's better for everybody. Anyway, I would say that 18 milliamps is probably okay. So we just want to basically make sure that the voltage across that input is higher than the input from the battery, and want to add a series diode to the battery. And right now the 470 ohm resistors not strong enough to pull the voltage up high enough to make it work properly. So I'll just put this back. Okay, this thing has gotten... Yep. There we go. Better. There's crap falling out of it. Well, let's just desolder that properly this time. Better. If you're having issues, if more than one guy is having issues streaming, let me know. Might have to change the encoding settings. If my connection is not keeping up, which is it's realistic, but it would not be keeping up. Right, so I now want to see what the actual loaded voltage is over the battery. That would be 8.26 volts. Now that's all unregulated, really, since it's just coming straight off a transformer. Why is that running off the transformer straight and not out of the 7815? I don't think the 7815 is even used for anything. No, there's just no 15 volt rail used anywhere. It's just for all this unpopulated circuitry. Every time you use the desoldering pump, I can't help but think of a cow going moo. That's a fair point. So the question is, should we just modify the circuit to run off of a regulated 15 volt rail? No, then I would have to heatsink the regulator, and that would be a bother. No, would I actually? Because, this is an oddity. No, there's not enough voltage actually available to make good use of these 7815. I'd have to use like a 7812. Although I could just put a 7812 there. That would probably work just fine, since we're not using the 15 volt for anything, literally. That would probably be a pretty easy way to get a somewhat stable voltage to work with, because it's difficult choosing a good resistor value to have in series with everything, since it's just going to vary so much with the load and the grid voltage. Please, what? The 15 volt regulator is feeding the 7805. Okay. Yeah, but other than that, it's just going to be unpopulated stuff. Literally just a couple of pads over here. So I think we'll just swap this 7815 out for a 7812. And reroute the 12 volt rail to go off of the that line instead of the unregulated rail. Then we'll choose a different resistor to feed the battery charging circuit, and then we'll put a diode in series with the battery, and that should work. Linear regulators. What's this? 1982? No, probably more like 1979. actually Win Famicom. There's a date code on the 7805, and that actually is from 1982. So yes, this literally is 1982. And well, I'm gonna dig out a 7812. I'll be right back. Well, that didn't go splendidly because I only have these little tiny TU-92 7812s. So the question is that going to be good enough without it dropping any voltage? Well, yeah, it's stretching the limits. Actually, I'm going to have to scavenge something. Fuck it, let's just try and swap the 470 resistor out for a 330 and see if it works. As long as we get more than like 9 volts on that rail, it'll be good enough. So, gonna desolder the vessel resistor. Moo. 360 ohm resistor going in. Let's check our voltage. .45. That's not good enough. What's our voltage drop across the resistor now then? 8.5 volts, so it's 8.5, 8.6, so I'm gonna have to see if we are drawing the same amount of current or if we're drawing less. Oh, we're drawing slightly more current. So that might mean that we're just hitting some kind of Zener regulator inside the actual timer module, which would be a bit of a bother. So, and for anybody who's just joining, I can see we've got 20 viewers now. We are trying to figure out how to make this little 9-volt battery connector not empty the battery by 20 milliamperes, even though the power is connected to this device. Perhaps an easier solution would be to just move where the battery is connected, because across there we should have a bit more voltage. 9.0, 9.1. So if we were to just connect our battery to the other side of this one diode and put a diode in series, then we would be just on the brink of not emptying the battery when it's connected to the grid, and this is a relatively good 9-volt battery, and we're just about at the same voltage. Well, you end up at about 9.6, I think, for a really full one. I better check. Yeah. But that voltage is probably going to go down when we turn on the relays. Yeah, now we're down to 8 point something. Oh, how annoying. Still hacking away, I see. Yes, indeed. Famicom, you are free to talk about anything you want, man. I don't care. This is an open forum. So, in order to raise the voltage, we have to just had another diode in series with the device, but that would be a bit ugly. Perhaps that's the easiest solution anyway. Heck, just hook up a 230-volt relay to the battery that disconnects it when it gets power. That would work, but I don't have any 230-volt relays. That would be a bit power inefficient. I think I'm just gonna add another diode in series with the timer. Or I could just lower it to a 220 ohm resistor. Now these are tough decisions. What's the voltage across the timer module anyway? And that's pretty spot on, 7.5 volts still, so I'm not sure I'm comfortable lowering the value again. Oh, fuck it, we'll try. We'll just put a like 270 if I have one. Nope. 220. Use a relay after the transformer then? No. I prefer doing it solid state if I have to. You know, the only reason this thing was discarded to begin with was the fact that it had bad relays, you know. What did I desolder now? Did you try hitting it with a blunt object? I have nothing really to suggest. I don't know what's going on. Well, Rex, we are just basically changing the current limiting resistor of a circuit, so there's just nothing to do except change the value of the resistor, raise the current, and raise the voltage, because the goal is to raise the voltage ever so slightly so that the battery won't self-discharge. It's really difficult to actually give a proper view of how the circuit is intended to work, you know, in a stream like this, when I don't have a camera that's actually easy to manage and like carry on my head or something. This was a new 330 ohm resistor, so we'll just put that in the right box. So let's see what the voltage here turns into with a 220 ohm resistor. What is the voltage going to the actual module? It is 7.8, 7.9, so it's slightly higher. Voltage drop across the resistor is, come on, contact please, 8 volts, so that will turn into 8 volts over 220 equals 36 milliamps. So it's drawing a bit more power. Quite a lot more power, actually. but we should have enough voltage now to make this work. Yeah, that's an acceptable voltage. Let's see what it turns into when we turn on everything. Yeah, that's about good enough. We could still just... I don't know. Yeah, it's not going to show up on camera, but the battery is going to be connected on one side of a diode, and then there's going to be power feeding the circuit. So I could just add another resistor in series after the first resistor, and that would give the circuit about the same... No, that actually wouldn't work, because we are... it would also drop a voltage for the battery. Yeah. It's a bit tricky figuring out how to do this the most proper way. I don't think the clock would be... I think driving with twice as high current for whatever the input might be for is going to damage the clock in the long run. It's not going to be good for reliability. So we'll need to change this around a bit, I do say. Although the voltage at the actual... Of course, we already have to drop a diode here in series with the clock. So what we need to do is reinstall the original or another 470 ohm resistor and connect the battery through a diode straight onto where the pin is, of course. This is so simple. Why didn't I think of that to begin with? This is stupidly simple. I can't believe I'm even bothering with all these convoluted, needless elaborations on such a simple problem. I've been overthinking this by an order of magnitude. Our original 470 ohm resistor going back in place. Sometimes the simple methods are the best methods, yes. So we'll just find ourselves a diode. I do have some diodes. these are like 4148s or something. They should be good for 20 milliamps. It works. And we'll just put it on there somehow. Gonna be a bit ugly. We'll just snip it there, and we'll give it a little bend, tin it, and put it into the circuit. And now we'll just, fuck it. I've got like really crap solder, and then I've got fancy solder. I want to be rid of a crap solder. One tinned diode, and I'll just put a lot of solder onto the two pads we want to solder it onto. Big fat blob. And I'll install it like a little pogo pin. There we go. I'll give you guys a bit of a better view. So, I have to. So the circuit I've been working on is like this. We've got our unregulated transformer input coming through here, then goes through this 470 ohm resistor to this point, which is just nothing, and then it continues through this diode onto the battery connector. So current can flow from the unregulated transformer out towards the battery. However, the issue has been that the voltage drop across this resistor has been so big that it's just been lower than the battery voltage, so the battery would be discharged. And from this point on, from the battery point, it goes through this diode here onto on its way out to the actual clock module. So what I've done now is I've added this red diode here, where I'll just connect the battery instead, so that we'll have this entire dropper configuration going all the way there, and then we'll just hook our battery in at the output of that entire thing. And this is always about 7.5 volts. Right, but that's no, that's not what. Never mind, that's not what I want to achieve. That's not at all what I want to achieve. That's stupid. I've made a stupid circuit. This will just discharge the battery even faster. Oh man. It was a stupid circuit. I'll just remove my resistor again. Stupid, stupid, stupid. Or what if we just put the battery straight across the power feed instead of the resistor with a diode? That would work if the current will drop. So we'll just put our diode in that hole. Oh, I'm blocking the camera. We'll just put our diode and battery in series with a diode straight onto the main supply of everything. No, that wouldn't work. That's not going to work because it's going to try supplying everything. So let's just unsolder that again. I'm getting a bit tired of this. We could just divide it up to 2 resistors instead. That'll work. So we're going to replace the original 470 ohm resistor with one 220, and then we're going to put another 220 ohm resistor after the diode dropper configuration. So there'll always be a 220 ohm resistor in series with the feed, but that way we will be able to get the voltage at the battery connector up so high that it won't discharge the battery. Hopefully the voltage for the timer module will still be high enough when it's on battery for it to actually work. We'll see. Give it a bit of trial and error. Oh hey, the stream health went to green for just a moment there. And we'll just lift this diode up a bit, like so, and we'll take a 220 ohm resistor, and put it there. This is beautiful. And now we'll put a diode in series with the battery connector as well. There's a pin in a hole which doesn't do anything. Let's just get that out of there. Put our diode in there instead. Diode. Battery. Right. We should now be able to connect the battery there without it self-discharging. It's just a question of whether or not the voltage is going to be high enough in the battery to actually make the timer work properly. So what's the battery voltage? It's way above 9 volts, so that's going to work fine. The voltage at the timer is still 7.5. So let's connect the battery. There should be no drain on this battery while it's connected to this circuit now. Well, and the power is connected, that is. So now it's drawing 10 milliamps when it's just sitting. And we do have a little it's changing a bit, which it seems to be something this circuit does. Like it changes its current draw as it's like taking the seconds forward, so that's a good sign. Let's just get another multimeter out to see what the voltage across the actual clock would be. As to hoping that it's in like somewhere around 7.5 volts. Yeah, 5 volts. It seems to be ticking, so that's a good sign. Let's just plug it in and see if this current goes down to 0. Yeah, we've just got the like slight reverse leakage of the diode. Okay, yeah, we've got nothing. 0.001 microamps. That's good enough for me. Now we're up to 15 viewers again. To anybody who's just joining in, we are not doing a Lipin LP838 unboxing. We are rather hacking this timer circuit to work properly with a backup battery. And we've also replaced these relays and had a look inside the timer module, and if you're just joining in, you've basically missed all of that, so you're gonna have to go back and view the recorded session if you're interested, but I don't expect you to be, so no worries. So let's try and program the timer and see if it keeps its memory, even though we cut off the power. Oh yeah, and also if you're just joining in, I almost gave myself a fatal 230 volt electric shock just in the middle, so if you're curious to see that, it's somewhere in the recorded session that's going to be available soon after I quit this. And well, let's just dim the lights again and have a look at the display while I'm programming this thing. So we'll just set the time for 13:37. Oh yeah, we need to set the date. It's Tuesday, 13:37, and we'll set that. Now it's ticking forward. So let's just kill the power. Display goes out. Battery current ramps up to 8 to 10 milliamps. As you can see in the meter, even though it's dark in here. So we'll let it run for like a few more seconds. See if it'll do something. I'm off to bed. Good night, guys. Enjoy yourself, Pin Korek. Right, let's turn the power back on and see. Oh, we still have our time. We're offline for 40 something seconds, it seems. Let's just see if it keeps up. If I watch the stream timer, what's it run to for like 15 seconds? We should be just over the 13:38 point. Oh, we should be past. Yes, indeed. So it seems to be keeping accurate enough time while it's running off a battery. And now it's not draining the battery while it's actually running off a grid. Because previously the circuit was putting an 18 milliamp load on the 9 volt battery while it was actually running off a grid. And that's no good. How does it work even though we put more load on the transformer? Yes, it does. So that would be a fixed circuit. So now all I've got to do is put it back together. Disconnecting the power so that I don't give myself another fatal shock. I guess it's going to be this kind of half-dead 9 volt battery that's going to be the official backup battery of this unit from now on. Oh well. I've gotten so used to using a lithium 9 volts that I barely even have any normal ones. No, that's my last alkaline 9 volts. Right, so back into the box it goes. It's a very industrial thing, by the way. And somebody's not taking a lot of care making this hole. It seems they cut the hole using, like they melted it with a soldering iron. There's been a lot of melting with soldering irons going on in this box, actually. The power is out. I'm still feeling the tingles in my fingers from that 230 volt shock. It's pretty insane. Properly terrifying, that. This goes in like so. Let's hope that it'll still fit with the new relays, because they're slightly larger than the old ones. And let's just squeeze this in. It's a very, very tight fit in this box. Extremely tight fit, actually. Yeah. It's in alright. Is the time module still going to fit on top? Oh, that's a very tight fit. Yeah, it's pressing against the relays, but it's going to be good enough. So I guess this old Finnish box now has relays out of 4 separate APC UPSs in it. That's a pretty impressive toll. But these relays certainly do more good in this timer box than they do in the crappy extension cord-like UPSs they came out of. Very proper box, by the way. They've gone to the trouble of actually putting metal inserts for all the screws, so they're not just threaded in plastic. Yeah, that one's ruined. Yeah, the threads on that one are just gone. Curious thing to note about the shock I got. This extension cord that I'm running everything off of is actually on a ground fault interrupter, and it did not trip. So at least I can be comfortable knowing that I wasn't receiving a lethal amount of current. But it was certainly feelable, even though it might not have been lethal. I am missing a screw. Oh well, I don't care. I'm gonna have to mount the battery somehow. There's no holder. No, there are 2 holes drilled in the PCB. That's supposed to be the battery mount. Guess we'll have to make do. I would not be surprised if the actual official way of mounting the battery was by just putting a piece of installation wire around it. I would not be surprised in the slightest. got to work with what you have. Yes, you do. Let's see if we can manage to wrap this wire through the holes, even though the board is already mounted. Gonna be pretty tight. You know what, I'll just solder this wire. That's by far the easiest way to mount it, because I'm going to have to take the board out otherwise. I'll solder it to ground. We've got a couple of holes available. I'll just wrap it around the battery. There we go. That's not half bad. Not going anywhere. I'll just give it a bit of extra. That's going to work excellently. Oh crap, it doesn't fit the holes. Ah. Oh well. Guess this'll be an SMD battery holder. I'll just put a lot of solder on there. It'll be alright. More solder equals better. Something like that. We'll just poke a bit in there. And hold it steady for about 5 minutes while the solder hardens. There we go. 1 battery holder, as per order. I should put a bit of tape over that diode we've got sticking up. Where are my scissors? Where are my scissors? Since I got that electric shock, I keep checking that everything's disconnected every few minutes. And if there's somebody new joining in, this is obviously not an unboxing of the LiPin amplifier. This is a hacking of an old timer unit, because I forgot to change the title of the video. And we've been doing a lot of fun stuff with this thing, and we're just about done. Just putting in the new backup battery. Click. That's a very good mount. I'm very happy with that. I'll just put the connector on. Like so. Oh, there you go. Backup battery mounted. Not super sturdy, but this is not a mobile device, so it's enough if it just stays there. And all I've got to do is put all the screws back in, or rather the last 4 screws, and this will be good to go. I'm gonna have to get a socket for those. And perhaps it'll do with one of these. Nope. The size 7. I think. The size, whatever that might be. go. Let's just give it a final test in its final mounted state, and I'll be able to end this stream. And for just it actually came with this little PTC type thing shoved into the power input. So I don't know if it's just an afterthought of a design, or if it's something they put there for extra measure, but I'm gonna let it be there. It won't do any harm. Alright, let's dim the lights. And here we go. The clock should already be ticking. It shouldn't start at 0. And it's apparently taken me 4 minutes 23 seconds to mount it. There we go. It's finally back together, ready to go. Big clunking relay box. And I'll finally get to set the clock for real. And according to my workbench computer, it's 0238. So, JPV, it's gonna be Sunday. 0238 KAS. And now it's gonna stay running until the battery runs out, I guess. Which is going to take a long time as long as I keep power connected. So this timer is now going to be used once I get some power outlets hooked up to it to turn on and off the power grid power supply going to my solar inverter in order to let me run the workshop on solar power whenever I want to, and indeed everything here is running off of solar power right now. So there you go. So with that, I think I'm going to just thank everybody for joining me and end the stream. The chat is going to remain open even though I quit it, so feel free to stick around if you want to. I'm going to go do something else. Goodbye everybody.